And I'm with my dad here.
Hey, how you doing?
All right, so to do implicit differentiation, you have to know the background knowledge and stuff, because there's prior knowledge needed to do this before you even understand what you're doing. So, background, do you know what a derivative is?
Yeah.
Yeah. Okay, so it gives you the slope of the tangent line, right, of a function.
Sounds right.
So when so to get slope of tangent lines of things that aren't functions like circles, you do implicit differentiation because the function, or it's not even a function, but the way it's written needs has more than one variable that you take the derivative of. So yeah.
Okay.
So yeah, that's what it means, and it's used to take tangent lines like circles to different places where you need like there's two values at value x, like there's 2 points at x, like if you go to x equals 2, and I'll get paint open real quick. If you have a circle here, and you want to normally the derivative gives you the slope of the tangent line at a point.
Right.
X, this is the x-axis, so if you wanted it at 2, well, there's 2 points at x equals 2. So the way implicit differentiation works is you have instead of the derivative gives you an equation to plug in. So 2x squared, f prime x will give you 4x.
Okay.
So this is the equation used to get the slope of the tangent line. So if you wanted at x equals 2 of this parabola, and then you plug in x equals 2 because there's only one value right here. You just plug in 1x, and the slope is 8. But for a circle, when you have two variables like y squared plus x squared equals 36 or something like that, then the derivative is going to give you something where you have to plug in an x and a y value because it needs to know what x value you're doing it and which y value it is to get the slope of that.
Okay.
All right, so that's what implicit differentiation is.
Okay.
So I have a couple examples here that I'm going to work out. I don't need to save that. Okay, so I have a couple equations. They're pretty easy that I'm just going to work out for you.
Okay.
So the first one is 3y plus 2x equals 36y. Okay, that's not a 6. No, I meant 2. 3y plus 2x equals 36y. See, it's right here. I drew it on Notepad.
I see it.
And now you know how to take the derivative.
Yes.
Yeah? Okay, well, it's the power rule, so y, the power of the y is 1.
Right.
And you bring it down in front of it, so you multiply the entire thing by that, and you lower the power by 1. So it's 3 y to the 1 minus 1 times 1,
Okay.
because you're lowering the power of it by 1,
Okay.
and you're multiplying it by the former power.
Okay.
So that would be just 3, because y to the 0 is 1, and you're multiplying the entire thing by 1, so it's just 3. But this normally doesn't happen when you take the derivative. You put dy dx here in parentheses because normally when you take the derivative, you take it with respect to x.
Okay.
So, it would just be y equals x. That's a thing. And then you take the derivative, and it's just 1.
Okay.
Because, you lower the power. And that's it. There's nothing else after it because it's implied that dx over dx is equal to 1. Dx divided by dx
Correct.
is 1 because you're taking it with respect to x. But since you're taking it with respect to x and there's two variables, it's dy dx because you're taking the derivative of y with respect to x. So dy dx.
Okay.
Yeah? So then you do it with the x variable.
Right.
So it's 2 times dx dx, which is just 1. So this is the same thing. It's the same thing as 2,
Okay.
which is like normal. And then equals 36y, so that'd be 36 times dy dx.
Okay.
All right.
Copy.
So there's the first example. Now the second example is y squared plus x squared equals 2x plus 36.
Okay.
All right. Now I realize you can put this in the normal form if you just get the y on the same value and then you take the derivative normally. But if you want to take this implicitly, which means you take it with respect to x and you do the dy dx stuff. Well, actually, hold on, I didn't even finish the last one. So you get the dy dx's. It's a 3 dy dx plus 2 equals, what was it, 36 dy dx. Okay, well, you have to do some work here because normally well, that's how you do it, but then you have to get the dy dx's on the same side and then you solve for dy dx. So you'd minus the 36, so you get negative 33 dy dx plus 2 equals 0 because I moved it over.
Okay.
And then I minus the 2, so it's negative 33 dy dx equals negative 2.
Okay.
And then I divide by negative 33 on both sides. Dy dx equals 2 over 33. So that's the slope. That's the equation you'd get to plug in, but since there's no variables, it doesn't matter. This is just the slope at all points on this equation. It's 2 over 33.
Okay.
All right? So, yeah, that's what you have to do after you do the implicit differentiation. The rest of it's algebra, and then the only part you do calculus is when you actually take the derivative. So, now back to the second one. It's y squared plus x squared equals 2x plus 36.
Okay.
So, you do the power rule. So, it's 2y to the 1, which is just 2y. So, dy dx, every time you take the derivative of a y, it has to be dy dx, unless you're taking it with respect to y instead of x. Then you do that for every x instead of y. So, and then you plus 2x, this doesn't need a dx because dx is just 1, equals 2 plus 0 because the derivative of any number is just 0. Because, it's power is 1, but that doesn't matter. But just, even the power rule is the only exception with just normal numbers. It's just normal numbers are always 0 because when you think about it, if you graph a normal number, like, where's paint? If you graph a normal number, if you give like y equals to 2, the graph is going to look like this, just a straight line at 2. Right. So the slope of the tangent line where it touches at technically just 1 point is just going to be the same line, and the slope of that line is 0 because it's not going up, it's not changing up, it's not changing down, Yeah. Actually, all right. And then you get the dy dx is on the same side. So 2y dy dx is equal to 2 minus 2x, because I minus the 2x, and it's all just algebra. Dy dx is equal to 2 minus 2x divided by 2y. And then this can all be simplified. When you divide a 2 out of every number on there, it's 1 minus x divided by y. So now, see, that is where you have two variables. Now, if you want to find the slope of the tangent line at a certain point, you need the x and the y of that point to find the slope of the tangent line there, Okay, so now the time is nigh. You have a solo problem to do, so I'm going to write down a problem on here and, try and help you. It's actually a bit harder than what I've been doing, so, I'm hoping you can do it. So we're e to the x plus y cubed plus 2x squared plus 21 is equal to negative 10 plus 3x. I can help you, man. Just
what about the power rule in that?
I mean, it mostly applies for most of the terms. I mean, not every one of those it applies to.
Can we use it here?
In some of those terms.
That's what I was thinking.
Okay, then go ahead and let's do it. You just gotta press enter and just type in what you think is going on here.
Okay.
Okay.
I can't really reach that well, but
all right. What the heck?
You gotta back up a little. That's right over that spot.
Now let's resume now. Okay.
Okay. So
you're gonna do this
so
problem.
I'll try. But it's a little bit out of my league.
And
I'm gonna go ahead and start applying the power rule to some of these individual terms.
Okay, what's the first term?
I'd probably go with x first.
What? You want? Okay, so you break down the x.
Yeah.
Yeah, and then you times the normal thing, and
yeah,
then
just
you
watch
minus
what
the
I-
power by 1.
Well,
you
look
know?
what I'm typing and tell me if I'm getting close.
Yeah, it's this. All right, that's wrong completely.
Oh,
I'm
what?
sorry, man. So I mean,
This is an
normal-
outrage.
Normally, what
This
you
is
gotta
not
do.
what I'm gathering from how you explain to me the power rule. Why
See,
is
man,
that?
I tricked you, man. See, this is a special exception with derivatives.
Okay,
the
you
rule
tricked
is
me. Some
the
things don't change in
the
this
der-
household, but anyway.
The derivative of e to the x is drum roll please. It's e to the x. It's the same thing. So the derivative is e to the x. But then you go to
This
the next one.
tomfoolery does not work well with me.
Yeah, it does. And now you're on to the next term. So
Let's
it's
try
y
it again.
cubed. Do you know how to do the power rule, man?
I'm
I taught you how
thinking
to do
I'm
it.
gonna go with it. So
So you bring the you
Watch
bring
here,
the
tell me if
power
I'm right.
down, yeah, this is
Okay.
pretty good. And then what's the next? Oh, good. Yes, you minus the
Thank
power
you.
by 2. Okay. But what are you forgetting here?
probably nothing.
No, you need a dy dx.
What?
Yes.
Well,
you
yeah,
remember
dy dx.
Every time you take the derivative
Oh,
of
yes,
a y
of course.
variable,
No,
you
of
gotta
course.
have dy dx. Now you put
You're
the
right.
plus sign back in there. Now what's the next one right here? We got 2x squared. What do you do here?
Well, I'm probably gonna deal with that x. You know what I
And
mean?
you gotta deal with the power, so
Oh.
you gotta bring down the power,
Power
which
rule-
is 2, and you multiply it by the 2x. See, look, there's a 4
Again.
right there. Yeah.
You got all
4,
right.
And then what's the power of 2 minus 1?
1.
1. So
Of
it's
course.
just x. There you go. But I mean,
Just-
dx
X just
dx.
represents 1.
dx is just 1, so there you go. And then
Right.
what's
Got
the derivative of a number? Just a number, like 21 right there.
21.
No, what's the derivative of it?
I'm going to say the derivative of 21 is
Nah, I just taught you this. It's 0.
0.
Bruh, I drew it on paint too. I was like,
I saw that.
I
That's
know.
what I'm saying. 0. I gave you drum roll first.
And now,
delay.
now what does it equal, right? I mean,
What do you think?
-10. All right. So
Correct.
what's the derivative? What's the derivative of -10?
Hey, drum roll.
No, fish. It's the same thing as a number.
Oh. Oh yeah.
Negative
10 is just a number. No, it's 0. What
0,
the-
yes.
what
I'm sorry.
the-
You can't let
And
this
then
record.
what's the derivative of 3x?
The derivative of 3x is 3.
Yes.
Yes.
Woo!
Thank you.
All right, now what do you have to do? This is basic algebra here. You just gotta get the dy
Well,
dx
that's a polynomial
on
equation.
the same side. You just have to get the dy dx by itself. So what are you gonna do here?
Well, I would.
Well, first let's rewrite it in a pretty way so it doesn't have any zeros in it. Right?
Yes.
You know,
Like-
just make them not there. Dy
yeah.
dx
Okay.
plus 4x
Yeah.
equals 3.
Equals 3. 3 on that one. Yeah. There it
Okay,
is.
so now
Mhm.
what are you gonna do here, man?
I don't know.
You
This
gotta
is
get
a lot
the
of pressure right
dydx
now,
by
but
itself.
you got to multiply that out, don't you?
You gotta
Factor it out.
subtract, So
What? No.
Yes.
No.
So you gotta
No,
subtract
when
by
you're
the
talking
e to
about
the
the
no, you do that last.
Oh, my bad. Okay, sorry.
So you got minus the e to the x, right? So
Okay.
it's 3y squared
Yes.
dy
minus
dx
x.
plus
Plus
4x equals 3 minus e to the x. All right, we're almost there.
Wow.
Now you also got to minus the 4x, you know?
On both sides, right?
Yeah,
There
man.
we go.
And then we go dy dx
Nice.
equals 3 minus e to the x minus 4x. Okay,
yes.
now what do you do here? This is the ultimate wombo combo move.
Probably
You gotta get
Solve.
dy dx by itself.
solve for dy dx.
Yeah, so how are you gonna do that?
Divide probably?
Yeah! Ooh, alright, we're gonna divide. So we divide by what exactly?
We're gonna divide by that 3, I think. The
3y squared? Okay,
yes.
cool, yes, that's correct. So we're gonna do 3 minus e to the
And I
x.
should have put my glasses on. I can't really see the screen that well, so when I'm trying to solve, I'm sorry if I've got some.
Yeah, I know, man. I I know the feel.
What?
Alright, so
you need
it's-
glasses?
No.
Well, we'll talk about this later. Okay.
So there we go. We have dy dx by itself, and you did this all by yourself.
Oh yeah, I
look at
mean,
that.
but it takes decent instruction.
Look at
right?
that.
Otherwise, I
Alright.
wouldn't have had a clue.
So there you go. Wow, you did it. And
Hey, thank you.
see now what you got to see if you wanted to solve for the slope of the tangent line. If you wanted to find the slope at a certain point, say we got the point 3, 0.
Okay.
X is 3,
Uh-huh.
Y is 0. What are you gonna do?
Well, you're probably gonna plug those digits in. I imagine those
Yeah,
numbers,
so
right?
there you go. 3 minus
looking at
e
it.
to the which value do we put here?
the x value, right?
Yes, because there's an x there.
Okay.
E to the 3, and I'll just put it like that.
Wow.
Minus 4 times 3. There you go. Divided by 3. Are we gonna put 3 here also?
I would
For
say
the-
yes.
No,
So
we gotta
it-
put a 0.
what?
Sorry. And 0.
What? You-
squared. And look,
Your old
it doesn't.
trickery again.
It's undefined. There is no slope of the tangent line. You know why?
Not really.
Because you can't divide by 0. You'll just blow up the universe. So
Oh.
you can't divide by 0. I'm sorry.
I don't want to blow up the universe. So
Yeah. See, dividing by 0, you just blow up everything
I
because it
don't
doesn't
do
work.
that. No.
Yeah,
Okay.
so-
It makes sense to me though.
There you go. You did it.
What?
Yep,
Thank you.
that's it. Wait, what would you grade me? Oh, wait, I'll grade you
As
as,
an
a student.
Uh,
As a student, no,
probably-
I'm grading you as a student.
Wow.
I'm gonna give you a solid B. A solid B.
Nice, thank you.
Well, you gonna grade me as a teacher?
As a teacher, I'd go A+, for
Oh.
sure, but I probably need to listen a little bit better. Plus, I
What?
needed my glasses. I just couldn't see the screen too well.
Yeah.
But
I'll curve it to an A minus.
Thank you.
You got a curve.
thanks. So you're gonna move me? Oh, that's nice.
Yeah.
You still stay in A+ though. Good job.
Alright,
good
cool,
job.
cool.
Nice.
Yeah.
All right. Thank you.
Okay, well.